Hello and welcome to Texas Instruments Talk in Embedded Vision Summit 2020. My name is Manisha Agrawal. I'm a product marketing engineer with Texas Instruments, and I'm so glad to have this opportunity to share with you all how Texas Instruments is making edge AI inference programming easier and flexible on TI processors. In my presentation today, I will cover the challenges that developers are facing with edge inference deployment, then take a look at advancement happening on open source inference framework side. Then take a look at how Texas Instruments is making edge AI inference programming easier and flexible on TI Jacinto 7 processors. Finally, we will take a look on programming experience with Jacinto 7 processors compared to desktop, and as well see some system level performance achieved on the first processor in this family. Developing deep learning based solution is a two-step process. In step 1, you create your model, and in step 2, you are ready to deploy your model. As a developer, you may decide to evaluate a couple of hardware to check which one best suits your system latency, performance, and power goals at your given cost budget before picking one specific processor to design your product on. So after you have narrowed down on some choices and ready to deploy your model, very soon you realize that each embedded hardware vendor has their own proprietary inference framework for programming the hardware, and you need to learn the tools before you can even begin the deployment process. Before I continue, I would just like to level set and clarify on the terms that I will be using, which is the inference framework. Inference framework is nothing but a collection of two sets of tools to assist with the edge inference. First set of a tool is optimizer, and another one is runtime engine. And each vendors name these tools differently. So as an optimizer, as the name suggests, it optimizes your trained floating point model to the hardware specific optimized model artifacts. The optimization step may include the hardware independent optimizations, hardware specific optimizations, and floating point to fixed point model conversion, which is nothing but quantization. Model optimization can happen ahead of time or during runtime. When it happens during runtime, then it becomes part of the runtime engine itself. And what is runtime engine? Runtime engine is a set of tools that is responsible to orchestrate the model execution on specific hardware. And it consists of tools such as APIs for programming the hardware, a set of optimized kernel library that implements the machine learning primitives like matrix multiplication and other on in an optimized fashion on that specific hardware.